So this video will walk through the final prompt. I may break it into two videos just because the final prompt's a little bit more detailed. But we'll see as we go whether we need to do that. So the final prompt, as you come down to prompt 4, seems deceptively simple. And if we were just thinking in terms of vector, it would be. But it's a little bit more complex to do this kind of operation in raster just because the way the data is structured. But I want to teach you how to get it done because it's very, very useful as you move forward. So what we want to do here is we want to return briefly to that grid you created in prompt 2, right? If you'll notice at the end of prompt 2, I told you not to delete it because you'll need it later. Right, so here was my prompt 2 grid from earlier. If you recall, all the values that were 1 meant that they developed between 2001 and 2011. So I essentially want to see how much of that development occurred within 5 miles of the Chesapeake Bay. Right, that's what it's asking here. How much land that developed between 2001 and 2011, how much of that happened within 5 miles of the Chesapeake Bay? Right, so Chesapeake Bay, we know what it looks like, this large kind of big estuary-like thing coming in through here, with all its little areas and tendrils coming in. So, if this were vector, right, we would just come in here and we'd, select it. But, right, we can't just select vector. That doesn't work. And then maybe we say, okay, well, I'll go to my raster table and I'll just find water, because I know the Chesapeake Bay happens to be water. And that kind of works, but then it also gives us a lot of other bodies of water, other lakes and rivers and things that aren't really what we're looking for. So it's a bummer. What are we going to do here? How are we going to get the Chesapeake Bay isolated? So in order to do that, the first step I would always say in something like this, right? Essentially what we're doing is we're trying to take the water values and we're trying to break them down by contiguity. So for those of you who haven't heard the word, right, contiguity, contiguous means connected. That's how we're going to solve this problem, right? The Chesapeake Bay and its related estuaries are in a sense connected to one another, while as the inland lakes would be separate. Right? They'd be their own kind of thing, their own little puddles hanging out here. We need that massive body here, right, that is not separated by other values to come out. So we need to take all of these pixels, these 7 million or however many it is pixels, and break them down so that this giant shape becomes one value. Maybe this little lake over here becomes another value. This lake becomes another value. I hope you can see what I'm trying to do here, right? Values that we're going to create in our new grid aren't just that you're water, it's that you happen to be water and that you're contiguous, right? This is a contiguous body of water that when you look at its edges, eventually stops being water, right? Eventually becomes forest or farmland or forest land or urban land or whatever it happens to be. It has a boundary that ends and therefore it should be treated as its own thing in the same way the Chesapeake Bay would. So we can do this in two ways. We could first reclassify just water, right? We could come in here, go to reclassify. Oops, my bad. Pick 2011, right? Make everything that's not water, no data, or 0. It might be helpful to do no data, no data, no data, no data, no data, no data, 1, no data. That would give us what we needed to work with. I'll call this just water. Right? That gives us exactly what we need to work with, right? We can see now there's that nice big contiguous body of water. That's going to hurt us a little bit. I didn't factor in the bridge into my calculations here. So unfortunately, we're just going to plow through it. We'll be a little bit inexact. You can blame Shay later for the foolish mistake right here. So we'll treat this part as the Chesapeake Bay and not necessarily that part. All right, but I've got my contiguous giant bodies of water right here. We'll, say south of the bay for this one. So now what I would essentially do is I'd go to something called region group. It's in generalization. So generalization region group. What is in common here is that all of these have a value of 1, right? 1 meaning water. If I didn't want to create that, I could do the exact same thing I'm about to do by coming into my land use from 2011 and just selecting the Wooder. Right? Then region group would know to only do it to those selected values. So you could do it literally either way. Select what you want to region group or reclassify if that's easier for you. So we've got our reclassified Wooder here. I'll drag it in and I'll say region Wooder. Number of neighbors to use, well, let's say 4 or 8. What does that mean? Well, let me show you. All right, when defining contiguity, oops, excuse me, that's another presentation. Break open my little PowerPoint from earlier. Right, raster is an imperfect form of geography, right? They are ultimately squares, and the smaller that you get, you don't notice this, but eventually there becomes a point when you need to ask yourself, what does it mean to be contiguous, right? And there's really two options about how we would define contiguity. So give me one moment while I just get this set up. Okay, so this one right here that I'm about to make like a blue color. If we wanted to define what was contiguous, right, what was touching the blue, I would pose the question back to you. In order to be contiguous, do you need to have, and just so that we're not confusing this, let's move maybe you down here. Should you be touching one of the 4 sides, right? We can all agree that's definitely contiguous because they're touching. But what about that? Do you actually consider that to be contiguous if their edges touch? Unclear. There's no necessary right answer here, right? There's going to be some instances where 8 makes a lot more sense and others where 4 does, right? Sometimes when you're doing like shapes that when they were vector were very serpentine, you know, like all I care about here is the Chesapeake Bay, but if I really cared about like water bodies in general or roads or something that's constantly moving around, I might do 8 so that I'm not messing with the chance to accidentally, like if it digitizes in such a way that what really is the same river makes it look like 2 corners are touching, I don't want it to screw itself up. So over here though, we'll just say 4 because all I care about the Chesapeake Bay. And we'll call it again region Wooder. So hit OK, it's going to do its thing, blabbity bloobity bleebity blabbity bloop. Right? This is one of those instances where ArcGIS is kind of being a jerk. It picked a stretched symbology, right, where it's stretched from the lowest to the highest. That's not really right, because these values here are meaningless. They literally only mean if I'm a 1 and you're a 2 and you're a 3 and you're a 4, it just means we're different contiguous bodies of Wooder. And so it's better to represent this because it can be a bit complex when you're understanding it. Go to symbology and pick unique values. Because every single one of these should be their own contiguous body of Wooder. And this will make it larger, but a little bit easier to understand. Now you can start to see where things separate themselves, right? By bridge or by another into one body of water or something else, they take on different values, right? So we can come in here, right, to these things right here, use our pointer and go here. You have a value of 3743. That doesn't mean anything. All it means is that you have that value, and so does that. And so does that. And so does that. Right, I can open my pixel inspector to be clearer. I could go all the way up and down this region lake, and they're all going to be 3743 because what they share is that they were contiguous. And then once I get outside of that lake, there are no values, it's no data, until I get over to this area, which is all contiguous. And so everything that touches each other here at a value of 3892 until I leave. That's region group. It just helped you identify clusters, right? Contiguous areas. So how do we go from here? Well, we've got 2 that are clearly the Chesapeake Bay, right? I've got my 164, and I've got my 4958. I don't know if those are the values that yours is going to do. Yours might be structured slightly different, but just use the pointer or use the pixel inspector, right? 164 and 4598, right? So 164, 4598. For me, at least. I don't know what it'll be for you. Oh. One 6 4 4 5 9 8. And the cool thing is we can just like literally use a, come up here and do a literal raster calculator to just get that out. But I could come up here and I could say, hey, I need this region water needs to be either 164, a meaningless value, right, on the surface. But what it actually means is that it simply represents this giant contiguous mass of green here, which is the northern Chesapeake. The value 4958, that, or 4598, the massive southern mass of the Chesapeake Bay. So use that little up and down, which means or. Region water equals 4598. I keep pronouncing that or getting the exact number wrong, so let me make sure, 4598. We'll call that Chesapeake. Hit OK, blah, 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 let it do its thing. Taking it a second longer than we thought, and exactly what we wanted, right? All the water we didn't want came back as like a dark black, and all the water we did was a 1. Awesome. All right, so we're almost there, right? We've got what will suffice for this lesson as the Chesapeake Bay isolated. Now we want to measure the distance, right? We want to be 5 miles from it. So the first thing we might do is come up here to distance. And I've got some big grids here. Go to Euclidean distance. And I'm going to set up an operation which is going to fail at first. And I want it to fail because I want to teach you guys something about Euclidean distance. Until you fully grasp raster, your instinct is going to be, okay, Euclidean distance measures distance. I want to measure the distance from the Chesapeake Bay, and because that's what I want, this tool will do exactly what I tell it to do. So you'll expect distance only from the blue area to be measured. You'll maybe say chest dist. Again, I'm going to let this one die. And again, we only need to be like 5 miles ultimately. I'm not going to set that up now, but eventually we'd set something up that would say 5 miles. Or, you know, why not? Just to make it be a little bit easier. So let's get a quick calculator up here. Do our 5 times 5280, right, because we're projected in feet. We get 26,400. So we say don't go past 26,400 feet because that's what we need you to be. Give it a second. Right, like I said, it's a large piece of data. What I'm doing here, I'm going to want to fail. So just, you know, if you need to get yourself organized or rewind in the video, this would be the natural time to do it while we wait for this. Now, here's how I'm going to show you that we failed, because it looks like we succeeded, and we're going to be celebrating and think so. And the only way I'm going to be able to do this is I need to arrange my classification scheme in such a way that I have the bottom value being 0, and I want that to be like a nice green. Right? That's going to mean no distance was measured, right, if it's 0. I hope we can all agree on why that's the case. So, interestingly enough, I measured the distance as 0 from everything. But that's not quite right, right? Only this blue area is the actual Chesapeake Bay. We didn't consider this to be, we didn't consider that, we didn't consider that to be, we didn't consider that, we didn't consider that, or that. But on the subsequent one, they're 0, right? So they're measuring their distance from each other. So therefore, a pixel like right here next to this little river, right, is saying that it happens to be 212 feet from the Chesapeake Bay, but that's simply false, right? The Chesapeake Bay, from that position, is all the way over here, right? It's closer to 245,000 feet away. It's not 210 feet away. What I'm trying to point out here is that when you use Euclidean distance, even though we only wanted it to really do it for the 1, right? Because the 1 is actually like Chesapeake Bay, and the 0 is other water. The tool doesn't know that. The tool thinks you just said, like, drag this in, and it's like, okay, regardless of the value, I'll just measure from all of these pixels. So when you're actually running something like, give it a second to delete itself here, Euclidean distance, and you're trying to run it on a raster, because you can run it on a raster or a vector, you need to just specify. That's what I want. Only run for those values. I don't care about the 0. That's why I'm selecting the 1. I'm selecting the Chesapeake Bay. And that way you can run the same thing. Bring it in here. Say 26,400. Right? I'm going to write over the other one. Let it do its thing. Bing, bada, boom. It'll process the cells. I'll show you what the outcome of it is. And then we'll probably start the next video right with it being processed, so just to save time and space.